Okay. Hello, everyone. Welcome to this week's nature seminar. And before I introduce this week's speaker, I'll just mention the last week, which is the last week of events. And two things. Firstly, next Friday at the usual slots, we've got Laura Martinez-Suz from Kew Gardens talking about mycorrhizae and the role of below ground biodiversity. But also an extra thing to mention is on Monday at the Martin School at 5 p.m, Julia Jones, who's visiting, will be talking about is conservation working? And that's a separate thing. So you go to the Martin School website and register if you want to go to that, either in person or online. And that's a Monday at 5 o'clock there. And we've got a wonderful program being lined up for next week's next term's speaker events. The one I'll mention, because I just got off a conversation yesterday, is Tim Smith, the founder of the Eden Project, will be talking about the transformative power of kissing frogs. So that'll be one talk to. But we've got an amazing lineup of speakers coming together for next term as well. Okay, so over to today's speakers. It's a great pleasure to introduce James Bullock, who's a conservation ecologist at the Centre for Ecology and Hydrology, which is based at Wallingford, quite near here. And he has a long history of work, both fundamental and applied, looking at rewilding, restoration, agroecology. He did his undergraduate degree at Imperial and his PhD at Liverpool, and then a bit of postdoctoral work with the Open University, working in Witten and Plumps nearby here. I just found out, and then has been at what was the Institute for Terrestrial Ecology, and then became the Centre for Ecology and Hydrology, where he's been for quite a while now. So I'll give it that. So thank you to James for joining us. Afterwards, there's a drinks reception around the corner, so do come and have an informal conversation with us afterwards as well. So over to you.
Thanks, Yadvinda. I think you can hear me. Hello, everyone. Nice to see you all here today, and thanks to Yadvinda for the invitation. So you can see the title is a bit of a buzzword bingo, isn't it? Rewilding, restoration, nature recovery, but hopefully isn't just buzzwords. These are all things which we're very interested in. And what I'm going to talk today a bit about is what does the future hold for conservation at a time of rapid environmental change? And particularly, what's the role of rewilding and restoration in dealing with that? It got this subtext heading here. We all know about biodiversity loss. Going to talk a bit about that, the drivers, what the future holds, or our lack of understanding of what the future holds, and what we might do about it. And right at the end, I'll talk about how we make it happen. And what I'm going to do is draw on work which I've been involved with. Mostly the examples will be here, but also some other examples. I'll try to make clear where it's my stuff versus other people's stuff. Obviously, the good stuff is mine. If it's rubbish, it's someone else's work. So biodiversity loss, we all know it's happening. It's terrible. It's rapid. It's not getting any better. But what's the extent and the future prospects across the world? Well, one project I was involved with, led by Forrest Isbell, is using slightly different approaches to actually going and measuring stuff, is trying to get the opinions of a range of biodiversity experts, people working on biodiversity conservation and loss across the globe, and asking them what their understanding about rates of loss and the impacts were for the taxa and the ecosystems which they're most familiar. And we asked them a number of questions, got quite a good range of responses. As you see, over 3,000 responses across a wide range of countries, conducting research in most of the countries across the globe. And one interesting thing was these estimates. They're actually slightly higher than the more quantitative, the data-based estimates. And that may be because people, biodiversity experts, are more gloomy than the data sets, but we also think it's because the people, less represented people in the biodiversity world from the global south, and also women, tended to give higher estimates, probably representing things which we know less about. So these experts estimated about 30% of species have become globally threatened or extinct since 1500. That's since globalization really started. And expect this trend to really continue quite strongly over the next decade or so if current trends continue. So we're not seeing this plan, hope for nature recovery that many people talk about. If current trends continue, it's going to get worse. And of course, this is terrible for biodiversity and species involved. And I'm going to focus mostly on biodiversity per se, rather than human benefits from biodiversity. But the other outcome of this is the overwhelming consensus, the last point, that this will decrease the function of ecosystems and also the benefits people get from nature. So I'm not going to focus on that. I'm going to focus on biodiversity as a thing which we should value in and of itself. What are the drivers of this loss? We know a lot about what drivers are involved. We don't know their relative importance very well, but the experts came up with quite strong patterns. So types of driver, land and sea use change, that's a general catch-all for things like degradation, destruction, conversion of habitats. And I'm trying to work out how to use this pointer thing. Where is it? There it is. So this, what these graphs show is the dark blue is where it's ranked first, then second, third, fourth, fifth. So what these are showing is that generally across our global survey, people ranked land and sea use change top, climate change next, overexploitation, which is hunting, extraction of natural resources, overfishing, those sort of things next, pollution next, or not pollution, as an invasive alien species last. And you can see this maps show that the global distribution of what people think about these drivers. So this land and sea use change on the terrestrial part of the globe is by far the strongest. Climate change, quite interesting patterns. So the boreal or the poleward areas, regions thought mostly affected by climate change, and then some interesting patterns elsewhere. And you go through all the others. What this shows here on the left is the sea areas, and you can see, interesting here, that climate change is the strongest driver there. So what to take home from that is that there's a quite good understanding of what drivers involved. There's some very strong opinions and thoughts about which are the main ones, and you can see land and sea use change coming through. But climate change is there, but quite interesting variation in what people think about it. So the standard approach to what we do about biodiversity loss, these drivers of biodiversity loss, is to say the current phrase is nature recovery. We want to do nature recovery. And the approach we've seen in this country and many other areas, and which is becoming enshrined in national and international law, is the idea of protected areas, where we have hive-off areas which we protect for nature, we reduce human impacts in them, and all well and good. And there was the famous Lawton Review quite a few years ago now, where there was a strong point made that for future nature recovery, we need to have these protected areas to be bigger. They need to be better, i.e. they need to be better looked after because they're not in not very good condition. There need to be more of them, and they need to be joined up, so with corridors or stepping stones or whatever in between them. And this is sort of seen in the idea of 30 by 30, which, if you haven't come across it, is this international agreement that we, all signatories, all nations that are signed to it, should be aiming to have 30% of land and sea effectively protected for nature by 2030. There's been a lot of excitement about this. I think the Wildlife and Countryside link in England are doing great work on this and showing this graphic here from the 2023 report. They say 3% of land is currently effectively protected for nature in England. And that figure hasn't really changed for the last 2 or 3 years. So basically, it's a great idea, but not much happening in this country. It's better elsewhere, but not here. So I'm going to talk a bit about climate change now and where this leaves us with this idea of protecting areas and aiming for nature recovery. So I mentioned just now that there's this general consensus that this land and sea use change is the major driver of biodiversity loss. And that's quite imbued in conservation thinking, I would say. And there was this paper, I haven't mentioned names here because I don't like dissing people in public, but you can probably find it anyway. There's paper in Conservation Letters saying climate change is not the principal driver of biodiversity loss. And let's use the verb tenses being used here. And they said, none of the arguments founded on climate change's wide-ranging effects are as urgent for biodiversity as those for habitat loss and overexploitation, which is fair enough. But we did a response, Aaron Thierry, Charlie Gardner and I, saying, why the hell are you saying this, basically? We need to think about the future, and the recent past is not a reliable guide to future climate impacts. And we said, I'll read it out, given the accelerating and nonlinear nature of climate change impacts, the recent past is not a reliable guide to future change. Conservation must look to the future if it is to successfully anticipate and mitigate biodiversity loss. And that's what I'm going to talk about, what that future holds and what we understand about it. And going back to that paper, I've lost my pointer, I mentioned just now with the global survey of experts, they were asked about global warming, climate change, global heating, I prefer to call it, and asked what they think the percentage of species becoming extinct or threatened would be under 1 degree, 2 degree, or 5 degrees of global warming. And you can see with what we're heading towards now, about 3. I know we haven't got a figure for that, but basically they're talking about quite large numbers. So that black line is the average, and these are the 95% confidence intervals, I think. So under 5 degrees, the consensus is about half species becoming threatened or extinct or threatened. And very recently, 17th of this month was officially the first day the global temperature exceeded 2 degrees above pre-industrial levels. And I think the next day it was also above it. It's probably gone down a bit if today's anything to go for in this country. But basically, we're heading very fast for very large levels of climate change. So given climate change and the fact we can't look to even the recent past for thinking about the future under climate change, how do we look to the future? Well, the classic thing is doing modeling. The people in this room do modeling. Tom in the front row does modeling on these things. So I'm going to run through some work we've been doing on looking about the future, to the future for the UK per se. And this is a project I ran in CH called SPEED. I came up with the acronym, nothing else. No, I came up with the idea as well. Spatially explicit projections of environmental drivers and impacts. And a very helpful reviewer said, that's not a proper acronym. But I said, so what? It's a good title. But no one, and of course my surname is Bullock, SPEED, I thought, but then no one funded SPEED too. So we all know that's a load of crap anyway, isn't it? So I've said that joke many times in the last few years, but hopefully it's a new audience. So what we did here was that the future isn't just about climate change, it's about other changes as well. And the IPCC has a so-called scenario framework where they think about climate scenarios, which we have all heard about, the so-called RCPs, relative concentration pathways. Is that the right word? I think the P is wrong. Oh, it's right, thank you. But also there's looking at socioeconomic futures as well, about how society may change, what our exploitation of the natural world may be. And these are so-called shared socioeconomic pathways. And what we did is we detailed these scenarios under the IPCC framework for the UK and put them together to get scenarios of how things like climate, land use, etc., may change in the future. So we projected future land use under these scenarios, looked at, we had pollution experts as well. They're doing work on heavy metal pollution and what that might look like in the future. And ultimately looking at possible biodiversity change, which is what I'll talk about. Just to show you the sort of stuff we've created. So we've got future climate scenarios for the UK. It's quite a nice, if that's the right word, quite a interesting map, which is temperature extremes, the top 10%, temperature extremes across the different climate scenarios. RCP 2.6 is the least extreme climate scenario, and 8.5 is the most, and those are in between. And these are different types of different models. So basically, if we do climate modeling we use different models and try to get consensus amongst them. So we've run different models. We've got lots and lots of data out for people, free for anyone to use who wants to use it, to look at the future. These, just for illustration, these maps show percentage of days from 2060 to 2080 for which the temperature is in the top 10 percentile of the historic. So basically, it's unsurprising it's going to get bleeding hot. You've got lots of extreme temperatures on the most extreme climate scenario, but even so, quite a lot even on the least extreme. And I think that's one thing which will come through, that even the least extreme climate scenario, which we're exceeding already, you're getting a lot of change happening. Anyway, people who are interested in data, there's quite a lot of stuff. We've produced high resolution, 1 kilometer, high temporal resolution, daily meteorology, all the IPCC scenarios and various other things, which I won't go into detail about, but it's all there and the paper's nearly out, but the data is already there if you want to use it. We've also done these shared socioeconomic pathways where we've got narrative accounts of what future societies would look like under these scenarios, quantified projections of things like, I don't know, resource use, population, building infrastructure, loads and loads of different things. And also we've used them, put together these scenarios to project future land uses as well, which again, that's all freely available for people to use. But most relevant today is we've also used them, these projections, to look at biodiversity futures. And one thing to really emphasize is these RCPs, 2.6, 4, 6.5, 8.5, are not saying this is what will happen. They're just a range of scenarios so we can explore possible futures. So that's what we've done with the biodiversity side of things. And this is, a lot of people use species distribution models, see what climate space species live in now, look at the future climate space and say, this is where the species could live. Is there anything left? How far away is it from the existing stuff? This is a rather complicated approach, which Tom here in the front is an expert on, so you can ask him any questions, because I don't believe, no, I do understand it, sort of. Basically, it's looking at whole communities rather than individual species. And so it's asking how, as you go over space from one point to another, how does the community of plants, butterflies or birds change? And how does that relate to environmental variables, especially climate? So it's compositional dissimilarity as species composition changes, how is that related to environment, especially climate? It's a bit of a hard one to explain. I don't feel I've done a great job here, but basically it's a great way of looking at how the future climate may be very different for species to live in as communities than it is now. And two things you can get out from it is disappearing habitats. One is disappearing habitats where you have the climate species live in now being lost in the future. So these maps show for the least extreme climate change, 2.6, the most extreme, 8.5, for plants, butterflies, and birds, the degree to which we're getting habitats disappearing for these groups of species under climate change. Let's see how many years hence, 40 to 60 years hence. And what this is showing is that plants, especially, we're showing a large loss of climate space, the climate space species can live in the future. Butterflies less so, and birds somewhere in the middle. And interestingly, as I said, even the least extreme climate scenario is showing a lot of change. And these are the means. So basically, you're losing half of your available climate habitat, if you like, climate space species can live in under these scenarios. We also have something which we call novel habitats, which is the flip side, where we have combinations of climate variables in the future, which we're not seeing today. So it's sort of unprecedented environments, climate environments for species. And again, biggest changes for plants, and the most extreme climate scenario is worse than the least extreme, but even the least extreme is seeing a big change. Not so bad for butterflies or birds, but still pretty bad. So quite a bit of a hard concept to grasp what this means. SVMs are much easier, but basically what these climate change scenarios, even the least extreme climate change, is showing a huge loss of climate space that species can live in, especially for plants, which are, of course, the base of the food chain. And what this just looks at the climate environment for species, not all the interactions. And that brings me on to the next thing, which is, as I said, those are scenarios of change. Climate scientists are modeling change and seeing how their models track what's happening, but there's huge uncertainty. And I think that's something as conservation ecologists we have to deal with. We can't pretend it's not there. So there's a number of levels of different types of uncertainty about what climate change will look like, and especially what the impacts on biodiversity will be. So this is quite a famous graphic, published quite a few years ago, which basically is called the cascade of uncertainty. So basically, as you go, you have some idea about maybe what future society may be doing, but then some uncertainty about what that means for greenhouse gas emissions. There's extra uncertainty when you decide which climate model you're going to use. Then when you downscale that to regions, and if you look at the different impacts and how you model that, and then if you downscale those impacts. So the biodiversity stuff sort of comes down here. You have all that uncertainty about what the future is going to hold, but then what the impacts are on biodiversity are even more uncertain. And I think we're always going to be living in that. We can't be precise. There's quite a big effort. Some people are really arguing for we need better models of biodiversity responses to climate change. But my feeling is that's always going to be a huge uncertainty. So how do we deal with that? And other uncertainties, what I talked about just now was aspects of mean climate, mean maximum summer temperature, mean minimum winter temperatures. What we know with climate change is bringing more and more extremes. So what's the impact of extremes on biodiversity? My pointer is no longer working. It's probably me. Yeah, the impacts of extremes like drought and fire, which we know are increasing. And there is work. There's actually a paper I saw out in Nature today or last week about impact of a cyclone on, I think it was on African mammals, and just the complex impacts of that. Generally bad, but worse for some than others. So we don't really understand what those extremes will do. We saw that those terrible wildfires in Australia a couple of years ago. Other things we don't really understand very much about is this goes back to that paper about the global expert opinion paper. And so we have all these drivers I talked about, climate change, overexploitation, pollution, land and sea use change. And generally, experts think these things will have synergistic effects. They'll have interactions which actually make things worse. And climate change is one of the major aspects of that. So the darker blue, the stronger that synergistic effect is. And synergistic is bad in this case because it makes the effects even worse. So if you basically, it makes sense. If you've got a knackered landscape and you throw climate change at it, it makes things worse. If you throw climate change at an area, then species, invasive alien species from other parts of the world are better able to establish and wreak their havoc. So those interactions are the drivers. We know in principle they exist, but what impact, precise impact there will be, we don't know. Another thing is whether species, we talked about these climate space species can live in and whether they'll exist in the future. And even if they do exist in the future elsewhere, can they actually get these new areas? And so we've done work in the past on the ability to track climate change. This is some modeling work we did that suggesting even for mammals, which are quite mobile, much more mobile than plants and many other things, on a relatively straightforward modeling approach, it suggested that 30% of mammals would be theoretically unable to keep up with climate change. So think of climate change as spreading in space. So where you can live moves somewhere else in space. 30% of mammals unable to actually track that. And that's over a landscape which is in perfect condition. If you've got it knackered, you've got roads going across it, you've got buildings, you've got sterile arable fields, that makes it even worse for them. So that's really the lowest estimate rather than a good high estimate. So probably even worse. And I think one last thing about this uncertainty is extinction cascades. So I talked earlier about plants, birds, butterflies. Then in these, what we were doing, they're not interacting. There's a nice, I say nice, scientifically nice, horrid, really, if you think about it as a normal human being, a really important paper, I thought, based on a big supercomputer model where they modeled lots of species interacting across the globe, and then through climate change at it. This is higher level of climate change, lower level, and then said, looked at what the primary extinctions were driven by climate change, and then said, well, if those species go extinct, what other species go extinct with them because they're dependent on those? And these are, if you look at the trophic level above 1A, things which eat plants and things which eat things that eat plants, you get very large co-extinction processes. So the dark blue is a 200% increase, which you're seeing across sub-Saharan Africa. But it looks okay for us because basically we screwed everything already, so there's probably not much demand on everything else. But basically, these extinction cascades are really important as well. So that's all terrible, isn't it? We know something bad is happening. We don't know exactly what impact it's going to have, but we know it's going to cause a lot of problems. So how can we do conservation in the age of huge uncertainty about the future? Well, something Charlie Gardner and I did was we threw the gauntlet down and said, conservation ecology needs to become survival ecology. Our argument here was that conservation, we might disagree with this, but we argued conservation is largely centered and often marketed on preventing species extinctions. But existing efforts have, certainly we haven't prevented biodiversity loss and extinctions. We may have slowed it, that's arguable. And from what I've just talked about, those prospects for preventing further extinctions become ever remote in the climate emergency. And that's the term I like using, climate emergency, not global warming or nice little phrases like that. It's a climate emergency. And we argued conservation should ultimately be about looking at the ecosystem level, promoting complex, well-functioning, and importantly, resilient ecosystems to help them adapt to climate change. And there's a bit of a throwaway to ensure ongoing benefits to humans. So it isn't just for the other 8.1 million minus one species in the world, it's for us as well. If we have these resilient, well-functioning ecosystems, we benefit as well. And so we said, let's have a paradigm shift in how we talk about things, moving from biodiversity conservation to what we call survival ecology, safeguarding a planetary system which humans and other species can thrive. And it's getting a bit of uptake. I'm quite impressed or pleased that this nice Oxford, very short introduction to biodiversity conservation done by Oxford's very own David MacDonald mentioned our paper there and said, Charlie and James wrote forcefully that Earth faces a climate emergency that renders conservation goals largely obsolete. Taken slightly out of context, it sounds more extreme than we said, but I stand by that. So, and this is what we said we need to think about in the climate emergency. So we talked about, rather than thinking about maximizing species persistence in the short term, we should be maintaining the conditions for complex life. So promoting adaptation and functioning in the long term, rather than trying to keep things as they are. And so rather than being reactive and seeking to prevent or reverse biotic change, we have to accept the reality of climate-driven biotic change and shape the outcomes rather than prevent that. And obviously, ideally, we prevent and stop climate change tomorrow. Currently around the world, in this country, and with various political elections recently, that prospect seems even further away now. So that's a sort of pragmatic approach. And We argued again about prioritizing future function, complex functional ecosystems, and maintenance of ecological and evolutionary processes, so nature itself can adapt to the future. And interestingly, that doesn't necessarily mean we change absolutely what we do, it's just the emphasis. So we talked about natural climate solutions. Yeah, protected areas are important, but they need to be adapted and adaptable to future change. But also things like novel ecosystems, which has gone from being anathema to people talking more and more about them. Rewilding, which again, not that much long ago was seen as a big, silly idea, has become more mainstream now. And I'll talk about that lilac box right at the end. So, recovery for functioning and resilience. So, one argument would be, well, conservation does that already. We're sort of, by looking after species and groups of species in a particular location, we are also allowing it to be highly functioning and resilient. So highly functioning is things like doing all the things a good ecosystem does, decomposition, gas exchange, using resources in a usually quite a tight circle, not losing a lot to the outside world. Basically, sort of ecology 101, or ecosystem ecology 101, I should say. And resilience is being able to respond to the different types of shocks and perturbations that systems get. So rapid onset, like when you get sudden disease spread through an area, chronic, like this is eutrophication of an area, and transitory, like fire. So different types of environmental change, and the ability to for the function to stay on that flat line and not really change, rather than go through rapid change, or for those of you into these sort of things, hysteresis of transitioning to an alternative state. What we argued in this paper a few years ago was that stability of species composition is not in itself a necessary prerequisite for the resilience of ecosystem function. Indeed, turnover of species and the communities might be the very thing that allows resilient functions. So maintaining the same species complement may not be what you need for keeping an ecosystem going, especially if the environment is changing greatly. So that's a sort of, in a sense, conceptually, what can we actually do to prepare for climate change and other drivers of ongoing drivers of biodiversity loss, and actually expand what we do rather than just do a sort of bit of a fortress approach. Restoration is one where we can, and I think restoration and rewilding sort of give us a way of thinking about what, even how we think about protected areas, rather than just keeping stuff as they are in protected areas, but actually changing and adapting them to be more resilient to future change. And I think restoration and rewilding, because they are all about change and moving a system that's become degraded to in a more positive state, they really can give lessons for wider conservation. The restoration ecology, ecological restoration, been around for a very long time. And we've got an International Society for Ecological Restoration, SER, that has its international principles and standards and defines restoration in the way you can see, assisting in the recovery of an ecosystem that's been degraded, damaged, or destroyed. And what happens usually for restoration is we have these degraded ecosystems. You can see on the top here, an area that's been mined, or coral that's been trawled, or a mangrove that's been logged, or a field that's been ploughed again and again for arable agriculture. And what generally the approach for restoration is trying to get that back to some, what SER called the reference state of a native ecosystem. Native is a bit of a dangerous word, but basically they're talking about what they think was there before. And this could be that native forest, a coral reef, mangrove swamp, or hay meadow. And we do a number of things, like we put soil there if it's become totally denuded, we put trees there, we create artificial reefs, we sow wildflowers and manage it. And this is a very rich area, huge amount of research and practice going on to allow us to get back to those native ecosystems. But we've argued recently, we have a project on it, that is that the way we should be thinking for the future? Should we be trying to return to some past which may be no longer relevant under climate change? And so we used this term of complexity, argued again, future restoration, we said should, it's probably a bit extreme to say should, but it'd be quite good if it did. You can't put that in the title of a paper, you get rejected. Enhance ecological complexity, what we call emergent properties at multiple scales. What do we mean by that? Well, what's complexity? I mentioned it a few times, haven't I? And people like saying, what do you mean by complexity? And people come up with really complex definitions of complexity. So I summarized here, we did in the paper, talking about temporal dynamics, spatial organization or structure of a system, using properties like Shannon entropy, dispersion, fractal dimension, network structures. And I've read these papers, I still don't know what they mean, but these really complex ways of describing complexity. Quite a nice one is the amount of ecological information in a system, but how the hell do you measure that? So in our looking through the literature, we thought there were two aspects that encompass the complexity of an ecological system, probably other systems as well, and that's to do with number and connection. So number is like the number of species, the evenness of distribution of species, evenness and abundance of the species, or at a larger scale, the number of habitat types. Connections, the number of interactions amongst species, pollinators going to plants, predators eating prey, decomposers decomposing different aspects of the litter, and energy pathways. And so we describe it quite simply as the number of components in a system and the number of connections amongst them. And that can relate to architectural complexity, how the number of sort of plant types you have in a system, functional groups, the different types of things do, and larger scale habitats, etc. And this graphic here has got a bit weird. Anyway, it describes that low complexity, you have one or two species in a system, like a standard permanent grassland in Britain, which would be like ryegrass and clover. That's low complexity. And then you increase complexity, you get more species there, and they start interacting in multiple different ways, and different species are interacting with other species, and one species interacts with three others, and etc. So you get lots and lots of things happening, and different types of interaction. It could be predation, it could be mutualisms, etc. And so this would basically, I think a lot of people who go into forests or complex grasslands would say, yes, that's how I see what's happening there. So, but we can actually measure it in some way. The same applies at the landscape scale. So low complexity, you have a few habitats with a few species in. Actually, probably those should be sharing species as well to make them even less complex. So it's very even everywhere. Then you get to a complex landscape. You've got lots of things happening in each habitat patch, and you've got lots of ways they're connected with corridors or stepping stones, etc. So you can apply this at different scales. And there's loads of literature out there about how complexity as defined in this way links to ecosystem functions and resilience. So that's what these blue bubbles show. So what we've got here is different ways in which I've just said you can measure complexity or characterize complexity, and information out there on how that links to functioning, production of the vegetation, decomposition, water cycling, pollination, etc. And also a lot on that, how resilient these functions are related to these complexity measures. So there's a good literature on those relationships. So this gives us a basis of thinking about, well, actually, if we can get complexity back, we can maybe get all these other things. And we're doing that in this project with a terrible, I didn't come up with this acronym, because it's terrible, REST-RECO, Restoring Resilient Ecosystems. I think I came up with a better one, but it was too rude. So we're saying, what do you need to do to restore complex ecosystems rather than just ones which look like some historical precedent? And restoration is usually always about time. You just wait and things happen. But we're actually thinking about, well, we want to speed things up. We want to get things going. So we may want to get more interventionists, putting things into the system which weren't necessarily there before, which is going to take a long time to arrive. People do that a lot in restoration, but usually in a very plant-based bottom-up approach. So do a diversity of approaches, and that's quite different from restoration, where we're saying this is the approach we use, I'm going to apply it. Let's do a range of different things to get a bit of a mosaic going. As I said, obviously, I lost my mouse again. Where's it gone? I'm pressing the wrong button. Oh well, never mind. Targeting complexity, so not these reference ecosystems, but sort of as my colleague Jim Harris from Cranfield said, basically what you want to do is an alien came to this planet. I don't know why I'm saying this, it's just a stupid analogy. But anyway, alien came to this planet, all it could see was complexity. That's what it may see a grassland in the forest and not actually be able to differentiate the two because they're both really nice and complex, but it will hate that field with just ryegrass and clover in. It means they are, I think this has died. Or is it? Oh, no, it hasn't died. I've died. It's adaptive. That complexity makes it able to adapt, well, more able to adapt to future change. And I think one thing I haven't really talked about, and it's probably a theme I should be really mentioning, is large scale. These things need to be done over large areas. And I'll get on to rewilding in a minute, as you can see. And that one great thing about rewilding is to think about large scale. And restoration needs to think large scale. So we can get lots of different things happening over large areas. How do we measure it? We've got the list of things here, some of which is used standard in restoration, but many other things probably less so. So the things like species richness people often look at, but I think quite a lot more we need to look at interaction webs. So this shows one interaction web of pollinators visiting flowers in a grassland. This is put together by my colleague Ben Woodcock, just showing a very complex pollination web. And other areas we've got very simple ones. Looking at the soil, what's happening down there. Soundscapes is, for those of you who haven't come across it, that's the latest big thing in ecology. So actually putting out recordings out there and seeing what sounds are going on. And this emerges quite a cool way of actually trying to encompass a lot of information. And this is another way in which we're trying to characterize complexity of the system. It works now. So that's restoration. We're arguing for pushing restoration from this sort of looking backwards to looking forwards. Rewilding is another really exciting approach. And unlike restoration, it's a bit of a, well, it's quite a new, it's been around for quite a while, but it really has come to the fore the last few years, especially in the UK and across Europe. And there are lots of projects, bottom-up projects going on, really, really exciting ones. And if you look around, you can maybe characterize them as I've got them here. You might be able to think of other ways people are doing things. So one thing is natural colonization, just allowing having areas, brownfield sites or arable land. This was arable land 60 years ago. Allowing it to recolonize naturally and seeing what you get. So the idea is it might be much more random, stochastic, variable, rather than just sort of standard thing by planting set number of trees or types of trees there. Getting wilder grazing going on, that's quite a common thing. I've got some pigs here, Mangalitsa pigs on the heaths in Dorset, going on rather than boring cows. But getting a range of different grazing or other herbivorous animals into the system, the idea they're going to create a mosaic of habitats, they're going to create disturbances like these pigs are doing wonderfully, and get a more dynamic wild system going. And of course, reintroducing what we think are key species. Beavers are the mammal of the moment in this country. I've got various colleagues say, well, various people who say to me, well, can we just put beavers everywhere? Probably put them in Parliament, it might make a difference. But yeah, so big interest in beavers, and of course they are great ecosystem engineers, as we know. But other key species, even predators. Predators a few years ago was like, oh my God, you can't bring lynx or wolves in this country. That's become much more talked about, and it's possible just because we've got this barrier between us and the rest of Europe. I think every other European country's got wolves now. I think that's right. I read the other day. Just us haven't. Sophie Monserrat might have shared these pictures with you last week. She works for Rewilding Europe. But there's some wonderful visions of what rewilding might look like in Britain and in Europe. So I've grabbed these off the Rewilding Britain and Rewilding Europe websites. They're probably copyrighted, so don't tell anyone. I'll nick them. So I'm not presenting them as my own. They're just, I think, beautiful visions. There's a cute little pussycat there. It's a wildcat, of course. There's a lynx up a tree with something. No, what is it? A fox it's eating. That's a bit cruel, isn't it? So these wonderful visions of a mosaic, complex landscape with all these different trophic levels, large predators doing things. This is a sort of a lovely vision of what rewilding might look like. Does rewilding necessarily give us this resilient, adaptive, complex systems for the future? I think a lot of people working on rewilding would say yes, but I think it's a bit more complicated than that. And so there's a paper I was involved in a few years ago where we tried to actually understand what rewilding might involve in order to establish these self-sustaining complex ecosystems. So rather than assuming rewilding will do it, what can we do to make sure it does? And this opens a whole can of worms about what people think rewilding should be. So this is just my take on it. Others will just like, rewilding is perfect in and of itself and you can't mess with it. But I think given what we're facing, what I said earlier, is we maybe should be thinking more carefully about that. Anyway, I'm running out of time, my God. So what we characterized rewilding here as, or it could be, is moving from a degraded state, that's an orangey triangle, to a more rewilded state on 3 axes. One where we have this trophic complexity, we have these predators and herbivores and grazers, whatever, which I talked about, which everyone talks about. Another is dispersed, allowing connectivity between areas, allowing things to move around, which is less talked about in rewilding, but certainly very important. I think one very interesting thing is disturbances. So disturbances in more natural systems are quite important drivers of diversity and change, and even bring resilience. Whereas actually in more managed systems, disturbance, we often try to stop disturbance, and that when it comes, it can be more damaging. And that's what these 2 pictures show. So in this top A, we've got a very managed, very modified landscape with these circles show the sort of trophic webs. They're rather depauperate, not many species involved, and they're not very well connected. And we've been holding off disturbance. A big disturbance happens. It's so major and it's such a poor system, it really can't respond. And actually that disturbance leads to a loss from the system, from which it may never recover. And that you can imagine that going on and on and on and on until that system becomes worse and worse. And those disturbances, those extreme events, what I was talking about earlier under climate change. Whereas a rewilded system, which has these components, those disturbances are probably less impactful, first of all. And because we're not trying to withhold them, like the old fire argument, if we try to stop wildfires, that could be quite a bad thing for systems. It may be better if they could happen in small ways frequently rather than massive ones occasionally. But these systems are complex and resilient enough that they actually can respond very well to those disturbances. And at the end, things recover well. And actually, one thing we haven't captured there, but that by setting things along different paths, those disturbances may actually drive more diversity in the system. So there's a vision for rewilding that actually seeks to build that resilience for the future rather than just assuming it will arise naturally. So this is a rather complicated table about restoration and rewilding, just characterizing the differences between them. And I won't really go into detail, but I think one thing I'll cover is that last thing, that we have a huge knowledge base for restoration going back, research and practice going back many decades now. The knowledge base for rewilding is much worse just because it's a fairly new thing, but rewilding brings a lot to the table. I like to think of it like rewilding is like the new kid on the block, or even the wild child with lots of great ideas and rushing ahead, and we're not quite sure where we're going to go with it. Restoration is a bit like the aged relative who has sherry every night, 7 o'clock, and keeps talking about the past. But can we get these 2 generations to speak to each other? And I think that could be really quite useful way of building complexity and resilience into systems. So Natalie Petterelli and I had a paper earlier this year where we talked about bringing together the best aspects of restoration and rewilding to actually get better outcomes on landscapes. So you can think of a degraded landscape here with, you know, not much in it, a few dead trees, a few remnants of bits and bobs around. And obviously we want to move that towards a better state. So the classic restoration approach, unless we've got billions or many, many millions to spend, we have to do that restoration in small areas because it's so expensive to buy the seed or buy the trees, whatever. But we can do that. And you get these little patches of quite nice targeted habitat creation. Rewilded, it's a bit more random, things popping up all over the place. I'm not quite sure what that is. It's maybe it's that alien I spoke about earlier. But a few random things happening over the landscape, but maybe that's rather slow and a bit patchy. If we do the two together, where we do restoration sites on different pathways and create biodiversity hotspots, but we have rewilding in the rest to soften the landscape, allow these areas to develop by their own accord, but they're also being seeded. And by seeded, I mean not just by the plants, but by the animals in these restored areas, can create quite a mosaic of different habitat types across the landscape. And that, I would argue, that mosaic helps you create a variety and a dynamic and complex landscape. And in some sense, that's what some rewilding projects are doing. They call them rewilding, but people are doing these different things. So it's not like this is a wild new idea, but just trying to conceptualize what it might look like. So I've talked a lot about restoration and rewilding and how that might help us think about the future and this uncertainty by focusing on complexity, resilience, etc. There are other key actions which Charlie and I mentioned, but which are talked about with the uncertainty of climate change. And I'm just going to touch on those briefly. You'll be pleased to hear. I won't go into great detail. Assisted migration or assisted colonization, novel ecosystems. And one thing which I think is fascinating, the idea of facilitating adaptation or even speciation. Assisted colonization, I've racked my brains a bit about this. It's not something that's been written around a lot. People have talked about it, but this is where the idea you think, oh, I don't know, capercaillies, they're not doing very well where they are, and they're going to do really badly under climate change. So I'm going to move them somewhere else to some new climate space for them. I think the trouble with that is, which species do we choose? Is it capercaillies? Is it some obscure little plant that a few botanists care about? Where do we move them to? What happens where you're moving them to? Is it how do you determine its suitability and what the impacts of you doing these single species movements? And of course, climate change is not going to be going like from this to this new state. It's going to be continually changing. The climate models beyond the end of this century really are extremely uncertain because we may have driven ourselves back into the caves by the end of the century, so maybe everything will be okay for the rest of the species on this planet. But as climate change, we don't know really what's going to happen. So how do we carry on moving them as climate changes? Do we say, oh, well, capercaillie needs to go over to Orkney? So I would argue maybe this sort of picking out individual species and moving them to track climate change is probably not very practical or sensible. And maybe this whole system approach, which brings it back to restoration and rewilding, is better. Novel ecosystems. So this is something that, again, is gone from a few years ago was seen as a terrible idea, but the idea that humans are creating new ecosystems which are unprecedented, we haven't seen before, even some of which contain non-native species, but actually seem to be functioning okay. They seem to be, if you think about it in terms of function and complexity rather than identity, they seem to be doing quite well. And Richard Hobbs in Australia has been a big proponent of this, and from being pilloried about it, that again has coming up the agenda. And so can we actually use this idea of novel ecosystems, linked back to what I was talking about rewilding and restoration, to purposefully manipulate systems for future conditions, and maybe even using non-native species? That's people are talk about that. Not all non-native species are the same. Some are analogous to things we had in the past year, which we killed off. And finally, something which is not my expertise at all, but just to bring to the table, can we actually help species adapt to climate change? How do we do that? Move populations around, create novel ecosystems. Can we even help speciation? Hybridization is a big thing. Hybridization's happened a lot in the past, and actually many Europeans and Asians are hybrids. We've all got a bit of Neanderthal in us. Well, many of us has, some more than others. So we are, it's argued, we actually are hybrids. That may have actually allowed us to adapt when Homo sapiens came, move into this harsh climate. That was the end of the ice ages. So hybridization, really nice paper. I wasn't anything to do with it this year, in Western Australia, where the work showed that hybridization of these narrow range endemic rainbow fishes, which you can see a picture of here, they hybridized with a warm adapted generalist. They basically, their genomics suggested they'd be much less vulnerable to climate change. So is that a bad thing? Are they becoming different to what they were? Good if they can survive climate change, or more able to survive climate change, or is it bad because you're losing the identity of that species? That second has been a traditional conservation approach. Maybe the first is maybe how we should be thinking. So what do we need? Well, what do we need for UK nature recovery under climate change? I'm emphasizing UK here because I'm loath to start saying what we should do in other parts of the world, just to really emphasize that. I think we can release a lot of land in this country for doing nature conservation and restoration and rewilding. And apparently there's a talk a couple of weeks ago, what's his name? Dustin Benton, showing, yes, that you could release a lot of land. So if you've got any questions, ask him, because he's not here. So in doing that, what we need to do is create a diversity of different types of ecosystem, which are heterogeneous, very variable and complex. We need to do that everywhere. And by everywhere, I mean when you have large areas, but also needs to be permeating through our cities, our towns, our agricultural countryside. And that's what I mean by multi-scale as well. It's not just certain areas we do it, in other areas where you just carry on screwing things. It needs to be assisted with reintroductions, introductions, moving things around, allowing connectivity. And this needs to be dynamic. We need to allow for dynamism in space and time to allow for resilience and adaptation. I'm gonna, final slide. How do we get it done? And you might think this is where we say, oh, we need to talk to the politicians and get them to do stuff. We tried that. So what do we as scientists have to do? Well, I think this is a very nice paper. I was involved by Aaron Thierry, Charlie Gardner, William Rowlandson, and Julia Steinberger, all very active in the climate and ecological emergence debate, saying that scientists or academics need to provide leadership about where we're going to go and getting change done. And this isn't the traditional approach of just providing information and ideas and providing the politicians with testing of their ideas. They're saying we need to engage in advocacy and activism and get much more out there and saying, we know what's happening. We are some of the best people, or not best people, we're the people who know most about what's happening. Sorry, wrong superlative. You know most about what's happening, so we need to get out there and tell people this needs to be done. And we need to really, in a sense, shove it down their throats. We can't afford to stand back. And they also say, since I am standing in a university, universities need to have a role in this, need to reconsider their role in society and explicitly recognize engagement policy and political process as part of the work mandate of their staff. So what this is arguing, and many other people out there argue, and I would argue, is that we need to get out there and get much more on the streets to say these things need to happen. We need to change, and we need to change now. And I said about climate change, we all know climate change is happening, and there are all these possibilities of what we might do. Obviously, the best thing would be if we could stop climate change tomorrow or next year, but soon. And that's part of this. It's not just saying we need to do conservation, we need to stop climate change. And the final thing I would say, even if we stop climate change, we still need to do all this stuff for conservation, because we've screwed this country so much in terms of our biodiversity. Even if you don't believe in climate change, which I assume you do, we still need to do all these things to get our environment back and to provide a home for all these other thousands of species we share this country with. Thank you.
Thank you, James. Really powerful point to end on. I'm sure there's lots of questions up there, so we'll open up to the floor. Any questions? Julia can kick off. There you go.
Okay, so I'll start straight away with that final point. So that call is quite a strong call, because it goes beyond simply engaging in the policy process and actually suggests engaging in the political process. But that's quite a, those are two very, very different things. And I'd just like to hear your reflection. You don't need me to tell you the arguments against becoming actively political in an academic public role, because of the, changes in political parties can then reduce long-term impact. That's well understood, and that's why often many academics try and avoid actual political. They'll stop the line at engaging in policy, but making evidence-based arguments, but not making political arguments. But I'd like to hear your reflection on that point, perhaps.
Yeah, so I guess it depends what you mean by political. And interestingly, on the way out, listening to a radio program where they're talking about lawyers and lefty lawyers, and the idea that these lawyers, by engaging with the legal process to help their clients, they're being called by the government lefty lawyers and being called political. So I think there is a massive difference between saying getting involved in political process and getting involved in that broad aspect of politics. And I guess in a sense, the activists would say they're not really getting involved in politics, they're getting involved in actually trying to make change happen. And whether it's Conservative in charge, Labour in charge, even if the Green Party was in charge, maybe if they weren't doing what's needed to be done, I think that's what it's about. It's about saying what's being done isn't enough. And we have some ideas what needs to be done, the minimum needs to be done. So really, you need to engage with that, rather than, I guess, the providing evidence as well. The policymakers saying, oh, we're doing something called 30 by 30. Could you give us some evidence around it? And then it's like, I don't quite like that, because that involves we've got to tell people stop eating meat. So can you tell us something different? And I'm not, that's something I've come across. I'm not going to give any more information on that, because it's probably breaking confidence. But so I think it's actually saying, rather than saying, what do you want to know about? Here's some information saying, this is what you really need to do, or you really need to engage with this. So I think it is a change, and it's something which a lot of academics are maybe not very happy with. But I think people like these guys are writing papers to really put forward those arguments. I should just say, at the British Ecological Society meeting in Belfast later this year, there'll be a workshop on engaging in activism and what does it mean for people in their careers. So something we can, if you're there, we can debate some more about that. But it is a bit of a change in mindset, but something I think a lot of us, I'm not saying we have to go through, but something I've gone through. I see no dissonance there.
Thank you for the talk. So I'm curious about the complexity. So you touch a lot about complexity, and in one of your last slides about it, you just said basically let's increase complexity without basically any baseline, without knowing no target. So how much complexity is enough?
That's a really good point, and it's in a sense, it's a bit like conservation. How many skylarks are enough? As a colleague used to say to me, how many of anything is enough? And that's something which the project with the terrible acronym REST-RECO were looking at, about what's the relationship between these complexity measures and these various other aspects of resilience and function. So is it, if it's strongly linear, then more and more is best. It's probably going to be some sort of plateauing thing. So that's what we expect. So I guess it's sort of watch this space. We probably need to, academically, need to try to understand what those relationships are. And we need to actually know how to bring together these different ways of measuring complexity and putting it into one basket. So the simple answer is not quite sure yet, but I think we can probably take our baseline from what we're seeing out there about well-functioning resilient systems, very few of which we have in this country anymore, because even our protected areas are generally highly managed, and if we step away from them, they're screwed. So maybe elsewhere in the world, we're actually looking at things which are better, more self-sustaining. So I think it's a bit of a non-answer, but I think it's also saying it's a work in progress. But I always say in conservation, we shouldn't wait for an answer, the absolute answer before going ahead. I think we know what to do to move towards complexity. So let's start doing that. And then as we gather information, we can start saying how much is enough. I think Michael's been waving his hand around for a long time.
Can you go back one slide?
I can. You like my acronym for that? DEAD.
DEAD, yeah, exactly. So I think this really
That is not simple. It just came up.
this really summarizes very well. So even if you do all of these beautiful things, you're still dead. I think that's the conclusion from your talk, I guess.
I mean, I think
Yeah.
I guess my point is I've said what I've tried to say throughout is that these are things which we can hopefully do to improve the chances of biodiversity, native biodiversity, etc., under climate change, etc. But this is all a bit like that. We're not quite sure, especially with the uncertainty about the future.
Well,
but this can put us in a better place.
But my question is really, when you look at the definition of the objective of the Climate Change Convention, it's about choosing a greenhouse gas concentration in the atmosphere such that ecosystems can adapt naturally. That's the first thing. And then comes food security and other things. And so I think we, the conservation biologist community, didn't do our homework, I guess. We did not inform, the 1.5 degree target or the 2 degree target. And probably there's a lot to be done on that, because the more we investigate and show, we actually see even 1.5 means dead. Huh?
Yeah, I agree. And I think it's one sort of thing that escaped the ecological community. I think the climate scientists took it over and they started defining what they meant by an ecosystem, like the Amazon is an ecosystem. And that's why we've got things like the Amazon dieback. So yeah, and I think one of the problems is ecologists, the troubles you ask them, that it isn't rocket science, it's much more complicated than that. And this, as I was trying to show, the more you dig into it, you've got extinction cascades, you've got interactions and things, but there probably is some sort of middle way where we can start saying, this probably, even these small changes are pretty bad. And maybe if we'd been there right at the start saying these things, it'd been 1.1, well, it's a bit pointless saying 1.1 now, but even 1.5 would have been not, the amount of danger for the other millions of species on this planet is much greater than expected. So yeah, but we are where we are now. So what I'm trying to think, dead is just, I thought it was quite funny how that came out, but it doesn't mean I'm too, I think I'm an optimistic pessimist or a pessimistic optimist. It's one of the two. I think we're screwed, but I think maybe we can make it less screwed than it would have been otherwise.
With zero emissions, you get dazed in that.
Yes. Yeah, that's good. Dazed and confused.
I think a couple are online. Okay, there's a couple. There's one from Ariel Diaz. In your opinion, ecosystem integrity and ecosystem complexity, are they similar concepts? And how much do they overlap? Because there's a lot of effort, especially in the GBF, has focused on highlighting ecosystem integrity.
I'd say, I think ecosystem integrity is very much linked with the idea of degradation. So it is, in some sense, linked to this historical state idea, that there is some perfect state this thing was in the past, which we want to return to, was I think complexity moves you away from that. So I'm not, it's a bit like health, soil health, ecosystem health. I think they're a bit of a weird, some of these concepts I find weird and immeasurable as well. And that's one of my problems with integrity.
Yes.
So I'd say
competition,
integrity might include complexity, but yeah,
yes,
I'm not convinced by that.
Okay, I'll take one more from online. This is from an anonymous attendee. We've seen this week with the COVID inquiry that national decision makers and leaders did not necessarily fully understand the scientific or academic information presented to them. What do you think the lessons are there for responding to climate change?
That's a bit of a big question. Well, I'm going to be political with either a big, is it big P or small P now? But I think what the COVID inquiry is saying is not that the politicians didn't understand, they chose not to understand. They didn't spend the time to engage. And this is one of my bugbears about when we as scientists or academics are told to engage with politicians. Great, engage with them, and we'll try to make sure we communicate in a comprehensible way. But the politicians have a job as well to actually engage with us and listen to us and try to understand what the hell's going on. And I think that showed really that failure. And I do find that that's part of the problem, is politicians not listening. And the terrible, I mean, I'm very political now, but the terrible amateur approach we have to politics in this country, where you have a cabinet minister who's just put in that post as a path to promotion to the next post, not necessarily because they have any expertise or knowledge to actually carry out the post. So I think the political process is problematic here. I think the scientists are less to blame. That's controversial because we're always blamed for not being able to talk to others outside our field and talk about generalized dissimilarity models as if people understand them, whereas only Tom does.
Okay, we'll take a couple more. So one there. You can.
Is this working still? Oh, my battery's died. Sorry, I use that.
I think that online you can do it.
Yep. Yes. So obviously one of the big concerns with rewilding, as you mentioned, was that the evidence base for it is still quite narrow, and for the approaches that you mentioned at the very end, obviously it's even more so. But given sort of with how quickly things are moving in terms of the biodiversity crisis and all of that, is there any point do you think there's sort of any point at which it's sort of a possibility on the table to sort of do one of something like intentional species movement without necessarily being able to test it fully? Like, is there any point at which you sort of just need to sort of hedge your bets because it's better than nothing, both for rewilding but also for the other stuff?
Yeah, that is a very interesting point. We had EJ and I organised a meeting earlier this year about nature recovery, and it was talk about, scientific evidence, what we need to do and whatever. And one or two in the audience at the end saying, we need to just do it. They were calling down the great god Nike and saying, just do it. And there is, I think that's a very interesting area, because traditionally scientists be like, oh, we need to get the evidence together. If we introduce links, what's it going to do? It's going to eat people. Is it going to eat cats? What are wolves going to do? How are we going to form packs properly? Maybe there's an element of where we just need to, with such a state, we need to just risk it. But I think with monitoring and close scientific overview is the big thing. I think if I was to criticize rewilding, which I'm not really going to do, is that there's loads of wonderful projects going on, but the scientific input and the scientific engagement is poor. And I'm a sore point, which Linda knows. I just heard this week a grant proposal I put in on looking at a rewilding project, trying to understand the processes, was turned down. And that's okay. Maybe I didn't write it very well, but I think I did. But I think that we've got great loads of bottom-up stuff happening, but there needs to be some way of getting the scientists involved to actually look at what's happening, understand the mechanisms, the processes. And that could be, so like, shit, things are going really wrong, we need to pull the plug now, or there's all these wonderful things happening, but we have some understanding of them. So I think, yes, do it, but do it with scientists involved to understand what's happening.
And so a quick follow-up. Do you think in that suite of sort of really radical approaches, do you think geoengineering at all is something that we should even be considering on the table? Because I mean, if you're to sort of changing habitats intentionally, is that really like,
Geoengineering. I'm gonna pull the ignorance card here and say I'm not that happy with geoengineering, but I'm no expert on it. So my opinion would be of a bloke down the pub, which after a few pints. So yeah, I haven't heard anything good about it. I guess that's what I would say. And it's probably a bit like carbon capture. It's a bit of a what's the word? That's a stupid idea.
Okay, I think if nothing more coming up, so I think we'll wrap up there. Thank you, James, for such a broad-ranging talk covering the challenge of climate change. I think this idea of how restoration and rewilding can complement each other is a really important framing for that, and also I think his ideas of what our roles are as sort of citizen scientists, activists in this whole process. So thank you for touching on all those points. And
thank you very much. Thank you.